Welcome to EDU World Space.
This question asks us to write an equation for the second electron affinity of chlorine. Then it asks us, would we predict a positive or negative energy value for this process? And would it be possible to directly measure the second electron affinity of chlorine? Start at the beginning. The second electron affinity of chlorine assumes that chlorine has already gained an electron. So we start with Cl minus. We'd be adding on an electron with its negative charge and forming Cl 2 minus. That's the first part. The second says, do you predict that this would be a positive or negative energy value? So I'm going to write this. This isn't formal notation. I'm going to write this as EA for electron affinity, energy, electron affinity energy, something like that. And this is the second one. And is this number greater than or less than 0? First, let's look at the periodic table. Chlorine here, number 17. So if you give it one electron, it has the electron configuration of argon. So that'd be a nice stable form. We know that chlorine does adopt this Cl minus form. But if you add that second electron, you're going to bump it, and you're going to put that electron into the s orbital, but you're also adding it to a negative ion already. So it would be reasonable to predict that this value would be greater than 0. That it's probably not favorable to add an electron to a chlorine atom that had already gained an electron. So we now put two negative charges on it, moving it past its stable noble gas configuration. So that's the second part. We're going to predict that the second electron affinity energy is greater than 0 or positive. And then the final part, it asks, is it possible to directly measure the second electron affinity of chlorine? Based on our answer in part 2 here, since this is a positive energy or energy requiring reaction, that indicates that this ion is probably not stable, that it takes energy to keep it in this state. So because this is unstable, we would predict that no, it is not possible to directly measure this value, E2, because its product is not stable.